Okay guys, this video is about solids, liquids, and gases. And this entire video will probably be review for you. However, we're supposed to cover it, so we're going to. So let's talk about the movement of particles. So in a solid, the movement of particles are just barely vibrating in place, but they are moving. That's probably one of the hardest things for me to imagine being true because I can't see it. They're moving fast enough to be able to slide past each other. And I can picture that because in a cup of water, or swimming pool, or an ocean, the waves kind of have that motion that just make me think, oh yeah, I can see those liquid particles moving. And then gases are moving the fastest of all, right? A gas is going to spread out as far as it can. So let's talk about how the particles are arranged. In a solid, the particles are super duper close together. They're squished in and compact as much as possible. In a liquid, these particles have a little room to move around like we were talking about. They're able to slide past each other. So there's enough space in between there to be able to slide past each other. In a gas, the arrangement of the particles is really spread out. Gases spread out as much as they can. Okay, so let's talk about whether or not solids, liquids, and gases have a definite volume. Remember that definite means unchanging, it doesn't change. So I have some blocks here, and I can put those blocks on top of a table. Notice they take up the same amount of space no matter where they're at. Solids have a definite volume. What about liquids? Okay, so I have a pail of water here. What if I poured that into the swimming pool? I would still only have the same amount of water, so the volume it's going to take up is the same. How about a gas? Now a gas, I can blow up a balloon, and then say I have that balloon and I let go of it. That air is going to spread out as far as it possibly can. So the volume of a gas does change. So what about definite shape? Okay, so we have some blocks here. Again, we're going to put them on top of that table, and they still are the same shape as a block. I can put it in a bowl. Still, same shape. How about that pail of water? So this water would be pail shaped right now. And then say we pour that into our swimming pool, and it's going to take the shape of the swimming pool. So liquids do not have a definite shape, meaning the shape changes depending on what it's in. How about our gas? So our gas is going to take the shape of the balloon when we blow it up, but when we let go of it, it's going to take the shape of the room, and it's going to spread out as far as possible. Okay, I hope you understand the difference in the similarities between solids, liquids, and gases. So the very last thing we want to talk about is plasma. Plasma is the fourth state of matter. It has positive and negative charged particles, and sometimes another word for plasma is an ionized gas. So here are the states of matter that we've talked about so far: solid, liquid, gas. As you add heat, it will change from a solid to a liquid to a gas, and then finally a plasma. Notice on the plasma, it is made of positive and negative particles. So that's why we say it's positively negative charged, and it is sometimes called an ionized gas. Here's just some examples of what plasma would be. The most common would be planets or the sun and lasers, but there are some other versions of plasma out there, and this kind of shows you where they're at. So here's some examples of some stars. These are pictures taken from a telescope. Also, realize the most common state of matter in the universe is plasma. Notice I didn't say the world, not our world, but the universe is plasma. And that's because it is in all those stars and suns and stuff.